Section 2.1, patterns and inductive reasoning. The objective for today is to use inductive reasoning to make conjectures. What is inductive reasoning? It's reasoning based on patterns you observe. For instance, if you are driving to school and you see the same person out walking their dog every single day, you're going to assume that they're going to walk their dog again tomorrow. So you're looking, you're watching. They might walk their dog, but they might not. But from what you have observed, you think they're going to walk their dog at the same time tomorrow. Here's another example. Problem 1, look for a pattern. What are the next two terms in each sequence? So it goes 3, 9, 27, 81. So when I look at this one, they are, I think, multiplying by 3. But let's check out the rest of them to see if it works. And it does. So the pattern is multiply. And you have to write the pattern down in words. The previous term times 3. Okay, so that's my pattern. The next term would be, what is 81 times 3? And that's 243. And what is 243 times 3? And that is 729. So the next two terms would be 243 and 729, and the pattern is multiply the previous term times 3. What about if they use shapes? So with this one, notice that we have a circle on the outside, we have triangle, then we have a square on the inside, then we have a pentagon in the inside. So it's not repeating any of those shapes, but if we look at the number of sides, the first one has 3 sides. The next shape inside has 4 sides and 5 sides. So what we're going to assume is the next circle contains one more sided figure than the previous. And you can word these lots of different ways. Okay, so that's my pattern. And then what I'm going to do is I'm going to draw a 6-sided figure. 2, 3, 4, 5, 6. With a circle, that's kind of ugly, but it works, around it. And we need 2, so then we need to draw 7. 1, 2, 3, 4, 5, 6, 7. Again, that's pretty ugly, but do your best. So I'm just going to go 6 and 7 just because I didn't do a very good job on those. Try the got it question. You can pause the video and then come back. What are the next two terms in each sequence? So the first one, 45, 40, 35, 30. To me, it looks like it is decreasing by 5. So I think my next two terms are 25 and 20. This time it doesn't ask for the pattern, but make sure you try to write that down somewhere so I kind of know what you're thinking. The next one has shapes. We have a square, and we then have a square with a diamond in the middle. Then we have a square with a diamond and then a square again. So I think they're just alternating back and forth each time. So my next two are going to look like a square with a diamond and then a square inside and a diamond inside that. The one after that will be the same, and then back to a square, then a diamond, and then a square. So again, it looks ugly, but just do your best. Try to be as neat as you can. What's a conjecture? I talked about that at the beginning. A conclusion you reach using inductive reasoning. Make sure that you gather data before making a conjecture so that you know you have enough information. For example, 1 and 3. There's not enough information given two numbers because you could add 2 to each number. You could multiply by 3 to get each number. So here, 2 terms isn't enough to get a pattern. Make sure you have enough so that you know exactly what that pattern is. Problem 2, look at the circles. What conjecture can you make about the number of regions 20 diameters form? So what we're looking at regions, they're talking about this. When you look at this circle, they're splitting it into 2 regions. The next circle, they're splitting it into 4 regions. The next one, they're splitting into 6 regions. Okay, so, and we're looking at how many diameters as well. So this one has 1 diameter. This one would have 2 diameters. And then 3 diameters. So make sure you look at how many regions there are along with how many diameters there were. So let's look to see if we can find a pattern between diameter and region. So going from 1 to 2, they could have multiplied by 2, or they could have added 1. So going from 2 to 4, it looks like they have multiplied by 2 again. And then going from 3 to 6, it looks like they're multiplying by 2. So if we then go to 20 diameters, and we multiply it by 2, we must have 40 regions. So don't go from 2 regions to 4 regions to 6 regions. You're going from how many diameters there were to how many regions there are. So be careful about that. Sometimes the first thing they give you is what they're turning into the second thing. There's a better picture of the diameters and regions. I just drew my own. Here's a got it question. What conjecture can you make about the 21st term? So we're looking for the 21st term. So RWB, RWB, maybe these are colors, red, white, blue, red, white, blue. So basically this pattern repeats every 3. So the first pattern covers 3. The second pattern covers another 3. So to get to 21, 21 would be 7 of these patterns. And it would be a full pattern. So I'm assuming that the last term is going to be a blue one. 7 full patterns equals blue. Or B. I shouldn't say blue. I just made that up. B. So the 21st one would be B. Now, if there's not very many, you could actually write 21 of these terms out and find out what letter's there. But if it had 150, obviously you would want to find a pattern to support that. Problem number 3, what conjecture can you make about the sum of the first 30 even numbers? So notice, let's find the first few sums and look for a pattern. So they're going to do a little table. So one term, we're looking for even numbers only, so would be 2. Okay. 2 terms would be 2 and 4. Notice the sum is 6. The sum of the first one is only 2. In 3 terms, we have 2, 4, 6. That's the first 3 even numbers. If we add them together, we get 12. And then the 4 terms would be 2, 4, 6, 8. We add them together and we get 20. So what we're looking at is we just looked at what is the sum and we found those. So how do we write those as some kind of product or some kind of pattern? Each sum is the product of the number of terms and the number of terms plus 1. So in the first one, the number of terms is 1, and the number of terms plus 1 would be 2, and if we multiply those numbers, we get 2. The second one, we have the number of terms is 2, terms plus 1 would be 3, and when we multiply them, we get 6. Now, this is a really, really hard pattern to do. I wouldn't maybe expect you to get this one right away since we've never really done them before. So we are looking for the first 30 even numbers. So we have 30 times 31, because remember we have to add 1, and we will get 30 times 31, which is 930. Now, obviously, you wouldn't want to write this one out and add them, so you'd have to find a pattern first. And again, this pattern might take you a little bit longer to find. Some of them are hard, some of them are a little easier. Here's quadratic question number 3. What conjecture can you make about the sum of the first 30 odd numbers? So when we look at this one, the first odd number is a 1, the sum is 1. So term and the sum. Okay, so the sum is 1. Okay, so second term would be a 1 plus a 3, and we get 4. The third term would be a 1 plus a 3 plus a 5, which would be 9, and we could keep going. The fourth term would be 1 plus 3 plus 5 plus 7, and then we'll see if we can find a pattern. 4 plus 5 is 9, 9 plus 7 is 16. So to me, when I look at these, 1 is the same as 1 squared, 4 is the same as 2 squared, 9 is the same as 3 squared, and 16 is the same as 4 squared. So I think these are moving up as perfect squares. So if we look at 30 odd numbers, it would be the same as 30 squared or 900. Again, that one's something that you have to recognize that this is a list of perfect squares. Tough to do, but once you've seen it, you might recognize it again. Problem number 4, sales of backpacks at a nationwide company decreased over a period of 6 consecutive months. What conjecture can you make about the number of backpacks the company will sell in May? So if we look at the table of backpacks, since these are decreasing, I am thinking that it will be a decreasing number, because in May, there's probably not a lot of people buying backpacks because the school year's over. But when we look at it, maybe it goes down to, for instance, 8,000 or something like that. And remember, this is a conjecture, so it's kind of a guess. If you said something around 8,000, you would be right. So it doesn't have to be exactly if you're making a guess. Now, could you do a line and figure it out exactly? Absolutely. Got it. Question number 4. What conjecture can you make about backpack sales in June? So, in June, maybe they're going to go down to 7,500 or something like that. Actually, I put that in the wrong place. I'm going to go like this. Oops. Oh, it was in the right place. Sorry about that. So June would be the next one. I would go maybe down a few hundred, maybe 7,500. Is it reasonable to use this graph to make a conjecture about the sales in August? Explain. I would say no, because in August, school is starting. August, school starts. And sales continue to jump up. So we would be having a decreasing line, and then it would jump up and decrease again. So probably not if you're following the trend that's going so far. Now, what's a counterexample? It's an example that shows that a conjecture is incorrect. So you have to find some example that shows that what you're saying is false. This is probably a little bit harder. What is a counterexample for each conjecture? If the name of a month starts with the letter, it is or I forgot the letter that they were doing. Let me see. A letter J. It is a summer month. Okay, so let's think about the months. Well, if we start at January, January starts with a J, and for us, that's winter. So my counterexample is January. You can connect any 3 points to form a triangle. Okay, so here's 3 points, and these definitely are a triangle, but what if we put them in a line. Okay, no triangle formed. So you kind of have to think outside the box sometimes for these as well. These are collinear. When you multiply a number by 2, the product is greater than the original number. So every time you multiply by 2, is it always greater, was what you're thinking about. So if we think about positive numbers, 2 times 2 is 4. 2 times 5 is 10. Okay, how about if we multiply 2 times 0? That's less. Or how about if we multiply 2 times a negative number? That's also less. So here's a counterexample. Here's another one. Either of those would work. And of course, you could have many different answers here. Got it? Question number 5. What is a counterexample for each conjecture? If a flower is red, then it's a rose. So again, you're looking for a counterexample. So think of a flower that's red that's not a rose. The first one that comes to my mind is a red tulip. There's lots of other flowers that you might be able to mention that are red but not a rose. One and only one plane exists through any 3 points. This one, you're looking for 3 points. When 3 points are collinear, the number of planes that can be drawn through them is infinite. So collinear points form infinite planes. Because you could go straight up and down through them and keep turning it all the way around in a circle, and there could be many, many, many of those. So a little description would work for that one. When you multiply a number by 3, the product is divisible by 6. So we're going to start multiplying numbers by 3. Let's go, first one I think of is 3 times 2. 6. 6 is divisible by 6. Okay, how about 3 times 3? 9. Is 9 divisible by 6? No. So my counterexample is 3 times 3. Okay, 9 divided by 6 gives you a decimal of 1.5, and 1.5 is not a divisibility of 6 or of 9. Bring any questions that you have tomorrow. Good luck.